So we're going to solve and graph a single variable inequality for algebra 1. And a single variable, just x. So there's no y's involved, no a's, no b's, just one variable x. So we solve these the same way in which we would solve an equation, right? Like if this said equal to, we just work to get x all alone. So I could subtract 6 from both sides. Divide by 2, and x is greater than negative 3. And then I know how to graph that. Here's negative 3, open and going to the right. Now, everything's the same. The one thing we need to be very careful about with these is if we multiply or divide by a negative number. Like if I told you 5 was less than 10, hopefully you'd believe that. And usually in algebra, you can do the same thing to both sides, right? So like if I add 2 to both sides of this, the relationship stays the same. 5 plus 2 is 7. That's still less than 12. But the trick happens, not the trick, the relationship to think about is what if we multiply or divide by a negative number? Like 5's here, 10's here, 5's less than 10. Move everything right to 7's here, 12's here, 7's still less than 12. But what if we go back to this original one and we multiply both sides by negative 2? So 5 times negative 2 is negative 10. 10 times negative 2 is negative 20. What we've done, here's 5, here's 10. When we multiply by a negative, we reflect the space over 0. So this 5 that was here gets shifted over here to negative 10. And this negative 10 that was over here gets shifted over here to negative 20. And if you'll notice, what happens is the relationship switches. So what happens when we multiply or divide by a negative number, this inequality switches. So instead of less than, now it's greater than. That's the one thing to keep in mind that we add on to this from just solving equations like we regularly do. Solving equations, these are inequalities. So for example, on this one, I'd add 7 to both sides. Negative 4x is greater than or equal to 16. Divide by negative 4. So that's all golden. That's an x, that's a negative 4. But since I divided by a negative, this switches instead of greater than and equal to, and now it's less than or equal to. And then I could, sketch my graph of that. Negative 4, closed, going to the left. All right, let's give this one a try. Distribute that 2. Distribute that 3. Let's subtract 3 from both sides. Let's get all the x's on the same side. And then let's get rid of that 6. So subtract x from 6, from both sides. So negative x is less than 6. But now, since that's a negative x, I want it to be a positive x. I could either multiply both sides by negative 1 or divide both sides by negative 1. It would have the same effect. And if I do that, notice this now becomes a positive x. This becomes a negative 6. And since I multiply by a negative, that switches. So negative 6 is here, open, going to the right. Again, the trick with these, the relationship with these, is to make sure that if you multiply or divide by a negative, you switch the inequality.